I think should be fine now.
Yes, sir. Can hear you.
Okay. I think I saw your mic being switched on, but I can't hear you. Um, no, let me try again. Maybe it's my side.
Can you hear me?
Wow. Can you hear me? Can you hear me? Testing, testing. Okay.
Yes, sir. Can hear.
Okay. Now it's okay. Thank you. Okay. I got 1 minute left before I start. Now, this afternoon, sorry about the last minute invitation, but we only managed to secure the stickers from analog devices. I think was yesterday morning. So we are still preparing the trying to finalize the details for this afternoon's talk. Now, this afternoon, analog devices have been very kind to actually get their senior people to come to talk to you, trying to tell you what they are doing. And also, I think that the fact that it also highlights the fact that the companies like analog devices based in Penang have a great need for people like yourself to join them. So if you look at the title of the webinar this afternoon, I sent out the webinar, I think, to the Google Classroom, so you should have a copy of it. If you have nothing going on, no classes of any sort, please at least join us. Just log in. I think it'd be good because you look at the two speakers here. They actually no, maybe I'll say they're actually our students before, right? So I have a picture here. So actually, Desmond was the E&E student. I think when he was doing his, I think let's look at it. That actually was SOT, School of Technology. So it must be a long time ago, 2011. 2011. So I think so it's a long time ago. Now he's actually doing quite well. He's an engineering manager at Analog Devices. Now, Miss Shelley Yeo was on the other side from the SAS, the School of Arts and Sciences, majoring in microelectronics. So in a way, if you are free, please come in to at least welcome them back, make them feel nice to say that here I am coming back to you to talk to you as a senior. So if you have the time, uh, it doesn't clash with anything else, just log in and say hi to them. I think they will like it. I mean, put yourself in their shoes. If they have spent a few years here studying here, and then they go out to work and they're quite successful. Now they come back and to see all of you. So it'll be quite a nice welcome if you can sign up. So the details I think I've given here. The details is here. If you can just sign up. So it will only take an hour of your time. But the main thing is they're trying to tell you what they're doing, so that maybe some of you may be interested to join them. They actually, you look at it, the technology companies especially based in Penang, it seems that there's a shortage of engineers. I think you may understand why. I think because many people find that engineering is actually quite challenging to study. And of course, it's not as glamorous as maybe a chef. I know, look at the TV. Reality show, the chefs will be doing very well. They have all this glamour. And then, or even accountants, you find that they are CEO of this company, CEO of that company. But again, if you look at the figures carefully, you find the engines are not too bad. There are also a few, many engineers who have been very successful running their own companies. So I think I will stop here and don't talk too much about them. So basically, if you can, I just want to encourage you to sign up to join us this afternoon at 3 o'clock. Because why 3 o'clock? Because I'm trying to find a time that most of you are free. So I also have invited the year 3 students, both the EE as well as the MH. So I'll stop here. I don't want to take much of the time. So this is just a bit of selling to tell you about this afternoon's what you call that, the webinar by Analog Devices. In the old days, of course, you'll be physical, and they can see the people, things like that. But now, of course, not. We are working in this new norm. Okay, for this morning, as you know, we have actually finished all our lectures. So I'm just tidying up a few things here and there to basically finish those things we have not finished. So this morning I will be going through the tutorial, one of the two tutorials we have not finished. So this is let's start with the tutorial number 7, which is on the support vector machines. So we just finished the lecture on support vector machines, so it'll be good for us to actually go through it, go quickly within this 1 hour. Of course, as usual, as it has been my practice, I would check with you if any of you have any questions on the previous tutorial or even lecture on the support vector machines, and also the tutorial on swarm intelligence. If not, I'll just go into this. So you should have a copy of this tutorial sitting in your what do you call it, in your email. I've sent up through the Google Classroom. So again, let's start with the first question. So the first one is give a concise and correct definition of support vector machines. What are support vector machines? Again, so such questions are actually very common in the first part of the exam question, because first part will ask you for the theory part. It won't ask you for your what I call the calculations. So the first part will be this: what is the concise and correct definition? Right. So you can also offer this is just straightforward from the lecture notes, of course, which I don't encourage you to do, but of course, some of you may try to do it. That means that during the exam, you may want to this and other questions. You may want to do a speed surfing, which you are not supposed to go surfing and find a different find an answer, which may or may not be correct, especially if you're not very don't have a good understanding of the topic itself. So you may find something that looks like it's correct, and then you just copy that and then use it as an answer. Excuse me, my voice. Okay, so if the best thing, of course, you look at the lecture notes. That is one of the better way of answering questions. So if we look at the lecture notes, basically the support vector machine, I think we look at it when we describe it as a supervised learning algorithm. Why is it supervised? Because you need to train it, right? You need to find the hyperplane, that can separate the two clusters of the data. So it is defined as a supervised learning algorithm, which can efficiently train the linear learning machines. So we are only looking at the linear learning machines in a kernel-induced space. So of course, the thing is that if I think the key thing is that because your initial data may not be linear, right? So if it's not linear, so similar to your perceptron, right? Remember the exclusive OR, which was not linear. So if it's not linear, you find that the perceptron cannot handle such a feature space. So another aspect of this is that which is different from your deep learning networks. It is you have to extract the features. So actually it's working on the extracted features. So I think we spent some time going through this. Basically, you have your first attempt. First attempt, you extract the features first, and then the features may not be linearly separable. So you then do a kernel, find the appropriate kernel to transform that to a different dimension. I won't use the word high dimension, but normally it's a high dimension, different dimension for you to able to separate them now using the support vector machines. Right. Of course, the challenge is, of course, you have to ensure that when you transform them to the new feature space or problem space, you have to ensure that you have to at least ensure you have to make sure, right? Or at least try to make sure that, or at least you hope, maybe the worst thing is you hope that it will be linearly separable in that new problem space, right? So there's basically what you call it, the general description to answer that question, which is what are support vector machines? And question 2 is actually this is actually very simple. It's just because I think one of the fundamental matters is that when you transform your, let me see if I can. No, this is not a PowerPoint, so I don't have my laser pointer. So, but I have my pencil here, right? So if you have your two initially, right? So the data points, the features in your lower dimension in the initial space have some certain relationship with each other. For example, x is related to x, sorry, y is related to x by this similarity measure of theta. So when you transform them to the higher dimension, to the new dimension in the new feature space, which hopefully it is uh, preserved, no, not preserved, it will be linearly separable. And at the same time, you need to preserve the same relationship, right? For example, let me give an example. Uh, John and not John, apple and oranges. For some, they are similar in the sense, or rather, quote unquote similar, because of course apples and oranges are not similar, but they are similar in a certain sense, or they are different in a certain sense. So that relationship must be preserved when you transform them from that low dimension to the higher dimension. And that is, of course, you have to make sure the one way to measure is your similarity measure, which is here shown here. You have two vectors, x and y, and then how do you uh, what do you call that, the measure, measure them. So this is actually if you look at the lecture notes, it's actually the magnitude of x times the magnitude of y, and you take the cosine of the angle between the two of them in that vector space or in that feature space. Yes, is that all right? Right. Now, I think we have also covered this. I also actually explained a bit more on the kernel space, the common kernels that can be used for SVM. So of course, you can talk about the linear kernel. You can talk about some of the what do you call that, the polynomial kernels. You talk about the Gaussian kernels, and then the radial basis functions kernel. Of course, your sigmoid function, our good friend sigmoid, sigmoid function is one of them. So basically, if you look at it, basically it's a transformation, right? Of course, you don't use some, not to say you won't use, maybe I've not seen, maybe because I've not seen using the same kernels that you use in your convolutional neural nets. Some of course, the sigma can be used, but other types of kernels that you use in your CNN, I have not seen them used in your support vector machines. Now, then number 4, look at the, I think we have to spend some time discussing this, clustering and classification. What are the differences? Of course, it seems similar. You're trying to group together, and then this group of data represents apples, and this one represents oranges. But of course, there are differences. Clustering is actually unsupervised, and then your classification is actually supervised. You know that each of these points represent apples, and each of these points represent oranges. But in the previous case of clustering, there is no way, you do not know. The points are just like that. For you don't tell them which one are apples, which one are oranges. So you have to figure out which one are similar and group them together, which you have also seen in the ACO, the end colony optimization, right? So these are, so back to this question, of course, if you ask you to discuss the major differences, so the keyword is discuss. So you have to talk about the differences, maybe also at the same time talk about the similarities between the two of them, right? As I said before, differences will be clustering is unsupervised, right? It's a method to identify a set or a group of similar items in your feature space, right? And then you do then classification is a what you call it, is a learning a pattern that maps an item or data point in that feature space into one of a set of predefined classes. So you know that this class is apples, this class is oranges, right? So far so good. Hopefully I'm not going too fast, but of course, please feel free to interrupt me, to ask me to clarify further, or sometimes I speak too fast, or sometimes I see things which might not make sense to you. Now, in the following table here, shown here in the figure Q5, there is data. So we have, what is this? So you can see here, we have used two features, which is the height and the weight, to um, dis- to to describe, right? To represent. The word is represent. To represent either a female or a male in terms of height and the weight. So now, of course, I'll ask you, why do we choose height and weight? Because from observation, you find that I think this one has to be very careful because you look at it. The this one only works within a certain community, a certain population, certain country, right? Because if you look at it closely, uh, I can say that what do you mean that? Uh, in this community, you can see here the height of the females are normally. Where's my pen? Okay, my pen is here, right? You can see that my until here, isn't it? Right. So you can see here, it's, it's actually. Let me see if it's too blur. That's no good. Okay, Mike. I think it's this fella again. My pen is that's why. Okay. And this one have to be no color. Okay, now can see clearly. Yeah. So can see here that the the females are normally what do you call it? No, I think that actually I'm trying to answer that. I'm trying to give you an example of the other way around. That the males here. Oh, sorry. There you go. Oh, sorry. The males here actually are of certain height, right? So in a way, you can say they are taller. But again, if you compare this to say people in Western nations, right? So the of course the such heights may be considered low, right? So they may not represent the males in that community or in that country. But in one country, you can safely say that there will be the males and females can be differentiated by the height and also the weight, of course. It comes together. So in this case, we have used two features here to represent the males and the females. So you can see here, they are actually we use extracted two features, right? Of course, this is maybe good enough, but of course, the trick is always the challenge is always those at the borderline that is close to the females which are taller, the females which are heavier, or even on the other side, the males which are lighter, the males which are shorter, short enough to be similar to a female. So those are things you have to be careful with when you actually look at it, the data. So in this case, we have actually, in this example, we actually look at those two. So this is two, two features uh, for us to say that who is a male and a female, and then use that maybe later on to actually classify correctly who's when a new data comes in, right? Now, this is now we have to identify the optimal linear hyperplane for us to actually, now we're trying to build a support vector machine now to actually able to classify, to separate, right, to differentiate the two groups of data, right, which is males and females. So first of all, you have to identify the optimal linear hyperplane and then identify, so you can see these are the steps, right? These are the steps for you to actually build your support vector machine. But of course, this is actually taking you, hand holding you to actually go through the various steps. Now, so how would you go about? Well, this is only basically only five questions are actually common. Finish it. So now, first of all, you have to identify the optimal linear hyperplane. So, how would you go about doing that? Right. So, of course, with the data here, let me see. How can we do this? How can we draw this out? Okay, maybe I can. Let me see. I have a zero. The height is 0 to 8. The same with my weight. So maybe I can do it this way. No, I can't. Maybe how do I do this? If I do it, I will keep flipping. Never mind. No choice. I will keep flipping it. maybe I can do it this way. Okay, let me try to draw this, right? Home, I did. Now, where's my, this one is an older version, is it? There you go, snapshot, right? Okay, so I can do a control. Oh, okay, missing. Let me try again. Okay. Okay, can you see what I'm doing? I'm trying to build that graph, right? To build the graph. Can I do that? No good, huh? So I can't draw this way. Let me try again. Otherwise, it'll be that's why I can see the difficulty if there's no graph paper. Huh? So the only way is left. I have to do it the old way. Okay. Change it back. Maybe I don't use this color. Use this color, and then I use back the straight line. No, not strong enough. Can you see? Hardly see, is it? Maybe I can use this the darker line. Okay. So I will go back again to use my snapshot to copy this, and then we'll have to paste through here. So I have eight lines. So I do another one. So again, while I'm doing this, it's also good to be reminded that please. Oops, where did my line go? Okay. This is no good. Why did this line come down here? Okay, so I got 4, 2. I need another few more. 2, 1, 2, 3, 4, 5, 6. I need 2 more. Right. Okay. I think this should do it. So I have my let's say the height from 0 to 8. I think I should have it. 1, 2, 3, 4, 5, 6, 7. Okay. Now I need to do the other fella. The other one is maybe I can do another one here. Rotate to the right. Oops, this is it rotates the whole page. Okay, let's try again. Do this the old way. So this one is 1. Can I do this? Okay. It even cuts this one out. Sorry about this. I know that it's very painful, can see. It's painful exercise. Especially you don't have the graph paper for you to do it easily. 4, I think I do it this way. 4, 5, 6, 7, 8. So I think you can guess what I'm trying to do. I have to build this, right? And then try to identify the optimal linear hyperplane, right? Where they are, right? So before I can do that, I need to be able to, of course, if you do it in a computer, of course, you don't have to actually, you cannot see, but somehow you're able to see, uh, maybe mathematically, the hyperplane. So now let's look at the points. So I have a 0.5. Can I cut this out? Maybe I can cut this out. So 0.5. So this is height. This is my height, and this is my. I need that, isn't it? I need to actually pencil will be this will be my height. All right, and then let's call this my weight. Right, so I have my first point, which is let me see if I can open up the other further. I can do it. I can watch from the other screen now, so easy for me. So I have my here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. Right, same thing here. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So if you look at the first data point, it's 0.5 and 3. Height is 0.5 and 3. So it should be somewhere here. See, correct? No, that's right. It's the other way around, isn't it? The weight is correct. Weight is 3, and then my height is 0.5, right? Weight is 3, and my height is 0.5, correct? Right. Second one is weight is 2, and then my height is 1.5, 2 and 1.5. So I got another point here, 2 and 1.5, 5.5, 5.5 and 2. 5.5 and 2 be somewhere here. 2.5, 2.5, 2.5 and 2.5 be somewhere here. Another point. My point and my last point will be 4.5 and 4.5 and 4. So I have my 5 points for the first set of data, first 4 rows. Sorry, 5 rows. Next one is 3.5, 6.5 and 3.5. 6.5 and 3.5. 6.5, 3.5 over here, right? And the next one is what? Next one is maybe let's try the other way. Let's try the other side. Let's change this. It's easy for me to refer it. This is change it to weight. Change it to height. So sorry, do this again. So now I'll use a different color. Okay, 0.5 and 3, 0.5 and 3 over. Point here, I got another point, 1.5, 2, and then the one is 2 and 5.5, 2 and 5.5. Another point is 2.5, 2.5, 4.5 and 4 somewhere here. Right. Then the other one is 3.5, 6.5, 3.5, 6.5, 5 and 9. Wow, the 9 is, I got a 9.5, which is, so hang on. I need to draw another line here. Right, so this is 9. 9. All right, and then here, so my 5.0, 9.5, even here. 6 and 7. 7.5 and 5, 7.5, 7.5 and 5. The last one is 8 and 8, 8 and 8. Okay. Now maybe to show a difference. So these are my two. Hang on. What's the first one is 3.5, 6.5, 3.5, 6.5. This is my male. So 4.5 and 4. So this is female, right? And this is my male. 2, 3, 4, and 5. Okay, now I think can see now. You can see easy to see, right? Easy to see where your expected hyperplane will probably sit, right? Now let's call this change the color purple. Let's call it purple. Let's call it 3.5, 3.5, 6.5. So this M1. Let's call this M2, M3, M4, and 5. M for male. So we do the same thing. Let's call this F1, F2, F3, F4, F5. Okay, so that is what I have. Right. Now, let's go back to our question. So now we will come back to question 5A later on, right? Identify the optimal linear hyperplane. But let's try the identify the support vector first. Because if you're able to define the support vectors, right? So you may be able to at the same time identify probably your hyperplane, the separating linear hyperplane. Who wants to try? So where do you think so maybe what color shall I take to differentiate? Maybe this green color and then use the thicker line to at least show the difference. So let's say maybe not. Sorry. This one I go back to red color. Now here I need my line, color, my green color, right? And then I use a thicker line here, too, right? Let's say I've chosen my optimal hyperplane. You can see here, this is my M1, M2, M3, and 4. So you can see this group. So here, so this is if I were to draw this, my concave hull. So this is my concave hull, one side, and then this is the other group. Right? So you can see here, therefore, my hyperplane will probably be somewhere here. Right? So question now. Can follow? Right? Question now. Let me see any volunteers before I invite some of you. Just flip the thing around. Kian Long. Oh, Kian Long is actually very good. Actually has signed up using 2 accounts to join the class. Kian Long, where do you think my support vectors are? And of course, when you answer them, you need to tell me how many you want to choose, the support vectors. Kian Long? No, not here. Who wants to try? Yao Sheng. Where do you think the support vectors are? So of course, when I ask you where the support vectors are, of course, you need to be knowledgeable, or you need to know what you mean by support vectors. So I've given you the first part. This is probably the hyperplane should be. Right now, the question now is, with that hyperplane, where do you think my support vectors are? Anyone want to try? Of course, first question will be, what are support vectors, right? Correct. So you have your F4, Jingwei, thank you. 4, 5, let me see his answer. F4, let me give a different color. Let me go back to maybe what color should I take? Okay, something this kind of color, I think different. Huh? It's a bit not so good. I think go back to black. Okay, now F4, F5, M1. F4, this one. F4, F5, and then your M1, right? This one, this one, this one. Any objections? Anyone say I have a different answer, right? Of course, uh, based on this convex concave hull, this will be the answer, right? You will see that this is the logical answer, right? So of course, if you tilt the line, can I tilt the line the other way? No, there's no other lines in it. Because if you tilt it, this one looks like it's the of course this question is quite simple, in the sense that there's only one line here, right? So this is it. So now we've done that. So Ken Long, Jing Wei, correct. So answer is go back to my color. Okay, so the answer so support vectors in this case will be let's see. Now I need to go back to the side. So this will be this is F3 is what F3 is what I need to draw it down here. F5, F4, and 1. F5 is weight is 2, 5.5 and 2. 5.5, 2.0. F4 is 4.5 and then my 4.0. Correct? 4.0. Oh, the other way around. Hang on. F4 is what? F4 is 4.5, isn't it? I don't have it. Let me see. F5, F4 is F4. This is F4. Which row is that? I'm trying to find out which row is that, right? 5.5 and then 2. Oh, so it's triplet, isn't it? Triplet. Somehow I got it triplet. This is my height, isn't it? My height is in this case height is 4.5. Right. So this is triplet. Let me erase this. F4. F4 is the height is 4.5. That's correct. 4.5. 4.0. F5 is over here. This is 2 and 5.5. Right? M1, the other support vector is here. Now, 3.5 and 6.5, right? 3.5, 6.5. Now, question for you. Why do we need to have 3? Why can I just take, for example, I only take M1 and M1. Maybe I change the color again. This will show you a different answer. What if I take only M1? No. Can you see? Too light color. I need to use stronger color. M1 and F5. Can I do that? What would be the consequence of doing that? Any comments? Correct. If you do it this way, if I only take this line here, if I take only these 2 points, I think, thank you. I think, was it Yao Xing? If I take only M1 and F5, you find that I can also have this. Let me see if I can draw this out. Purple color, let's say. If I take only these two as my support vectors, I can actually have another one here. Just right here, right? I can do it like this, right? So it's and also I can have another one here, something like this. Yeah, So you can see basically you're not locking in. You're not locking in the line here, the hyperplane, right? If you have 3 points, that's why look at it. 3 points seems to be the minimum number for you to lock which line are you for you to select, right? Whether it is this one here, or this one here, right? So here now I think it's a bit tricky if I go to erase now. If I go to erase, it's a bit tricky. Let me see. I can erase this further. All right. This one is oh dear. I need to move this back. Let's see, can I do this? Okay. So I just need to. Okay, right. So that's why you cannot take only 2 points. Huh? Is it clear now? Any comments, questions, clarifications? Okay. So that's why we take 3 points. That's why going back to Jingwei's answer, he go and take 3 points because you can see here 3 points here. I can only take or actually. Can I take, interesting, I just realized I can take F4 and M1, right? F4 and M1. But there's a separate discussion. But I can look at. So of course, easy for us to see. Easy for us to see that maybe I can take M1 here, and then take my F4 here. So this one will lock it. But simple process will be just take three. Take any 3 points. So I got these 3 points, which is go back here. And I can see it. This is my back to my red color. So this will be M1 will be 3.5, 6.5 is the first one. So this is row 6, right? And then this is what? 2.0, 5.5, row 3. And F4 will be to 4.5, 4.0, row 5. 3, 5, 6. So actually we are selected. We're selected 3, 5, and 6. So these are my support vectors. Right, so I have so this is row 3, row 5, and row 6, right? So it's this is my optimal so-called optimal hyperplane, right? So now once you've defined that, the next part, right? If you decide that is your chosen hyperplane, linear hyperplane. Now, if I have new point here, so what is this color? So black, and then put a black here as well, right? So we have another one now. So I have a data now. Someone has a weight of 7.0 and a height of 8.0. Is it a male or a female, right? So based on that, how will you answer that? You have to answer it based on the hyperplane that you have chosen, right? So in this case, you have height is 8, will be somewhere here, and then your weight will be 7.0. So 8 is here, and then here, this will be here. Oops, sorry, no good. Okay, let's draw a bigger one. Okay. Okay. Right, you can see here. So this point here. So based on that hyperplane, so this will be a male, right? So this will be based on that, based on the hyperplane. Go back here. So we can see that based on the linear hyperplane, it is a male. Okay. So any questions, comments? Let me have a drink first. So please, you can see either this question or other questions. You need to have a graph paper. Of course, I've seen in the past
How is the points on the line? Good question. So basically, I think Yao Xing, good question. Huh? So now basically come back to this. Back to this. So his question is what happens if the points on the line? There's somewhere over here. So if you remember, we have always defined the line itself is they are more than 0, then you're less than 0. So we have these two cases very straightforward. So now what happens equals to 0? This is on the line itself. What Yao Sheng is asking, right? So this one is so I would say up to you to decide. This is a boundary point, right? So boundary point, you can include the this point here, right? It's either male or female. If you choose male, it's okay. You can choose female, it's okay, but have it consistent. Does that make sense? Right? So it's always that this fella is always a problem, right? Sitting on the line. Good question. At least get me thinking also. So this is basically, in a way, if you look at it, basically is the function again, right? Once you define this, right? So if equals to 1 or no, call it class A, class A, class B, right? So class A is more than 0, class B is more than less than 0. So in this case, we have a more above the line will be males, below the line will be females. So his question is what happens equals to 0, right? So we can define it as such. Sitting on the line, you take whichever you want, right? Good question. Anything else? Any other questions before I continue? Now the next one is a bit trickier. I'll take a long time to erase this one first. 50 minutes, I think just nice for us to at least do part of it. I think easier to do this way. So those of you who come a bit later, there's a talk this afternoon, 2 o'clock, not 3 o'clock. So basically also at the same time, it's basically 2 of the students are coming back to actually give a talk to you. I think Desmond Ui will be quite happy to see some of you. I mean, see in the sense your screen presence. So please, if you have nothing much to do, please support and then at least show up. Give them a good welcome. Now the next part is actually determine the distance of the support vectors to the appropriate hyperplane. So we're trying to figure out the this fella. This. Oops, sorry. How can I draw this? It's a bit tricky. Can I draw this? I can see. Okay, basically, it's my. Oh, sorry. Not used to. Oh, sorry. I dropped my line. I've got my line. Oops, sorry. Oh, no good. Okay, let me draw again. Try again. This is my height. Oops. Cannot. I'll just draw a line. Change my line to be different color, blue color, let's say. You see. So you can see I'm trying to find this distance. This is my distance of the support vector to the appropriate hyperplane. So take this one, or what's that? This one. Is it? This one, right? So I have call it D1, D2, D3. Yeah. Of course, whichever you take, right? It depends on the point you want to take, right? So how do we go about doing this? This one, if you look at it, so first of all, you need to identify the 3 support vectors. In this case, we have done it. So let me color, brown color. Okay. So go back here. So first step 1, identify your support vectors. Identify support vectors. That's where your starting point is. So we say that our support vectors is upper to. Our support vectors is row 3, 5, 7. So you have your, let's call it row 3. Which is row 3, 5. No, 3, 5, 6, isn't it? 3, 5, 6. So 5, 6, 6.5. The second one is 4.5. This is 4.5. And then this is your row 5. Row 5, correct. And then your row 3 would be 2.0, 5.5. Row 3, right? This is my row 5, and this is my row 6. So this is my equals to my support vectors, right? 1, 2, 3. Now, if I would then remember, you have to put in the what you call it, the extra value. Okay, will be then your S1 tilde will be equals to 3.5, 6.5 vectors. Don't forget vectors. 2, S3, and your 4.5, 4.0, 1. Sorry, this one it will be 1.0. Okay. The last one will be 2.0, isn't it? Right. 2.0, 5.5, 1.0. Right. Oh, no space over here. No space. Insert blank page. Done. So now the extra page. Okay. Now, what do you do? So what do I think back to in a way back to Yao Xing's earlier point. So now we say arbitrary. We say that S1 to be class -1, right? So this one you have to see. This one is actually our male, isn't it? So let's call this class -1. So this is female. Let's call it class +1. So this is also our female +1. So that's why we get the 2 classes, sorry. And that's why, remember, you have to change it, transform these vectors into the appropriate equation, which is alpha 1, S1, S1. Actually, it's a tilde, isn't it? And the plus or alpha 2, S1, S2 plus alpha 3, S1, S3 equals to my class -1, right? You repeat the same thing for the other 2 classes, the other 2 vector, the other 2 support vectors. So you have your S2 now times your S1 plus alpha 2, S2, S2, alpha 3, S2, S3. Now this one will be your class +1. Finally, the last one. The last support vector. Sorry about the handwriting. It's also part of the digital pad, not very sensitive. So no matter how much I try to writing nicely, it doesn't come up as nice. This is 200. S3, alpha 3, sorry. S3, S3 equals to +1. Okay, now you will do that. 5.5. So now if you were to substitute values of your S1 and S1, S2, S3, you get something like this. In the interest of time, Yao Xing, how is the points on? Okay, I think no, I think I've just saw the old message. Okay, fine, no questions. So if you were to put in the substitute the vectors inside here, so what I get is that you get something like this. 0.5 alpha 1 plus your 42.75 alpha 2 plus my 43 point. Can someone, you can try if you want to, right? And of course, I think it should be correct, If not, let me know. 40. What else do you see here? Basically, it's a diagonal matrix. So this one will be transferred over here. 0.75 alpha 1. The last one will be here. 43.75 alpha 1. See that? Over here. This one will be here. And your plus your, this is alpha 2, sorry, S2, S2. S2, S2 is new. So you're going to get 37.25 alpha 2 plus the last one will be 32. This one is my data class 1. So this one is here. So this one should be here, 32 should be here, right? That's my here. As I said before, this is a what I call the balance matrix or diagonal matrix. So this will be over here. And then the last one will be S3, S3. S3, S3 will get you 35.25 alpha 3. This is your plus 1. Now, of course, now you got to, what I call you have to try to find out what's the value for alpha 2, 1, 2, 3. So you have to do a bit of transformation. Basically, I think to cut the long story short in the interest of time. So we have, what I have was something like this. Alpha 1 give me minus 1.10. Oh, sorry, it's not the final answer. Where's my answer? Oh, sorry. Digital pad not very sensitive this morning. Alpha 1 will be alpha 1. Alpha 1. Okay. Alpha 1. Where's my alpha 1? Okay, my alpha 1 should be, okay. Let's see here, alpha 1. Okay, there you go. I think, what is it now? Alpha 1 is minus 29.1496. 291496 minus 29.2416. Oh, sorry, can you see that? Very bad handwriting. Sorry again. It's the digital pad. It works slowly. 1496, 291496, 2911496. Like slowly 1496. Alpha 2 equals to, what is alpha 2? 1079. 107950. I always use 4 decimal places. Sorry. 10, 26472. 26. 26407. Is that correct? 261. So that's correct. So I have my 3 alphas solved. So we have to solve that. Now we know that the linear hyperplane, that the separate each class is given by this general equation. There is your here. So you can remember this. One more space a bit. You know that it's actually
given by this. This is my general equation. Alpha I S I, and then I equals to 1. So in this case, it will be until 3, right? So therefore, we've expand this, not sensitive, alpha 1 S1 plus alpha 2 now. Sorry, 2 plus alpha 3 S3. Now, you have your S1, S2, S3. So therefore, substitute inside. What you get is you get your W. So this is actually matrix, our vector. The W1 will be, or not right, our vector. This one will give you my it's a vector because it's a vector. That's your this one is a 3, isn't it? Your S1. You go back, right? So you can see here I have 3 values here, right? This will also be so you get your W1 will be, you should get this 0.6, oops, sorry. 6, 3, work slowly because I'm not sensitive. This is not right. I find that if you don't have a power source to your digital pen compared to those with power source, it actually works better. In case you want to buy a digital pen for yourself. W2 is what? W2 is minus 1 point. Work slowly. 0, 5, 2, 6. And finally, W3 would be 8.05 to 6. Right, we've got the solve. So therefore, with that, I can now, okay, I need another page. Running out of space, blank page, okay. After, right. So now I have this. Now, so therefore, my hyperplane, the equation will be that hyperplane that Yao Shi talked about, that actually sitting at the 0 will be this. So substitute this, you get hyperplane, hence hence the hyperplane will be, so you can see very bad, more sensitive. This, remember the X, Y, and Z. So it should be, this will be my X, my Y, and my C, or constant. So you have your that maybe I'll do it here. I write here, easy for you to see. I could refer to this. So I have my, basically it's a W1 X plus W2Y plus your W3, which is your K, constant equals to 0. This is your line. Right, so what do you get? I get this. I get minus 0.6. Sorry, 316. Very bad, not sensitive. Minus 1.0526y plus 8.05.
Okay, good morning, everyone.
This is the line.
Can you hear me?
This is a hyperplane. Anything above that will be one class. Below this line will be the other class.
Yes,
so rearrange this.
Okay.
Rearrange this into this form.
I think we don't need to wait for others lah. Maybe you all are busy with something else. Okay, we just start with this past year.
You have your
just discuss regarding your coursework. I'll let you know by 5 p.m. today. They have something to check before I release to you.
This is my mistake.
Okay, I think we stop at
this form so that I can then apply the equation to calculate
we have
the distance
to
that
question 3 on
the
Monday.
hyperplane.
Then let's continue on question.
Or this hyperplane to that any other points. Orthogonal distances.
Hydropower dams have been criticized for their social and environmental implication. We know that
very slowly.
You build a dam, you will impact a lot on the environment. Discuss 3 possible solutions to mitigate the negative impact of hydropower project on the environment.
7
So
point
maybe you can suggest how we can reduce the impact
equals to
on environment
0.
based on this dam, what we can do.
Now, then we
Okay,
know
first,
that
what's
distance
the
will be,
problem
the
of the
occurrence
dam?
distance will be
What's the
equals
impact
to the
to build
distance.
the dam? So you
Let's
can
go
see that
again.
first, you will reduce oxygen generation.
A
You will release a lot of
M
methane gas
plus
during the first few years of
N
operation, because
plus
all the
C
plant is
over
submerged underwater, which they
square root
die
of
and decompose anaerobically.
A squared
So they will release the
plus
methane gas.
B squared.
And
So
then
this one
it
you have
increase
to
the water level.
we
If
actually shown
impact
this.
to
This is the actual
the
orthogonal distance from
marine,
any point to that
not marine,
line.
maybe river
So
ecosystem.
now if you
the
select
fish,
the
then the
point
water level
which is
change, they have to
3.5
stay in the different
and 6.5.
pressure level. Okay, so it's
Now go
actually
back
is
here,
quite
6.5, 3.5.
impactful for some of the fish, but
So
some of
this
the
is
fish
my,
they can stay in where have high pressure or low
6,
pressure. Nothing
3.5,
much for them.
6.5.
And then we also
3.5,
reduce
6.5,
the
this point here, this point to
water
this
level
line,
at the
right?
downstream.
So you have
Okay,
your,
we affect the
so your M and your N will be
river ecosystem.
3.5 and 6.5. So this will be the
Okay,
distance to
then
them
there's
will
a
be
danger of the dams collapse and sediment pattern. We change the
0.5.
sediment
Now what's
pattern,
A? A will be
which
here. See that?
the farmer can
0.6.
use as a fertilizer. And these all are the problem of this
way back.
that
Plus
the negative impact of
this
the
is
dam.
6.5, right?
So
6.5.
you need to
Yes.
propose 3 solutions for this.
6.5. Now my second one is
anything that we can propose.
Y is actually what? What's Y? Right? It's 1. So times your 1.0. Then
You can see that read carefully.
C
for your
here
answer
will be minus 10.65.
First, you can see that it talk about hydropower dam have been criticized for their social
right?
and economic implications.
So divided by.
Then second sentence, discuss possible solutions to mitigate the negative impact of hydropower
A
project.
squared. A
But
squared
it
will
didn't
be
say that must be the
A will
hydropower
be, B is 1,
dam.
right? B is
So
1.
that I think the first thing you can think of, yes, I do not want to build the dam.
Now A
so
is,
if I don't build the dam, it means that I
0.6,
can reduce impact
right?
to
Which
the
will be
environment.
0.6
Which
times
maybe I
0.6
can
squared
use
will be
the runoff river system.
0.36. Now this
Okay,
one
which has
give
the
you
much lesser impact to the environment.
a distance of
Okay, what else?
0.8146.
Maybe
Now
we
the
can
same
plan
applies.
properly,
You can take any of the other
land
2
use
points.
around the river
If you take
basin
any of the 2
upstream
points, you give you the
of
same
them,
answer. So I think with
by
that,
protecting the nature
stop here.
environment in the river,
Right.
watershed,
So,
and erosion can be
again,
better
before I
contained.
stop,
And we also can
just a
remove
reminder,
all
this
the
afternoon there's
plant
a top webinar.
before
Please
we build the dam,
support the top,
so that
right?